Hai korang, so hari ni kita nak sambung lagi kita punya tutorial dan saya nak masuk kepada period of simple harmonic motion. So kalau kita tengok dekat dalam kita punya nota, we can see that the period of simple harmonic motion, we have two types lah. The first one is for the simple pendulum, and then the second one is for the mass spring system, like this one. So let's go to this one. So for simple pendulum, we have length. This is the length. So the equation is this one. I'm going to be very short and very brief. So the equation for pendulum, we have L over G. This is the prominent parts. Of course, the equation is T equals to 2 pi set L over G. And then the next one is the mass spring system for this one. So the equation for that is T equals to 2 pi set mass divided by the spring constant. And remember that the spring constant, the unit is Newton per meter. That's it. So let's start with our tutorial. Alright, let's do this question. The length of a simple pendulum is 75 centimeters and it is released at an angle of 8 degrees to the vertical. And then we have to find the period of oscillation. So it's quite straightforward. So this is period for pendulum. So question A, period equals to, 2 pi set L over G. Okay, so we have the length is 75 centimeters. That would be 0.75 divided by G, which is the gravitational acceleration, and you should get 1.74 seconds. So it's quite straightforward. Let's go to question B. Dia kata, the pendulum bob's velocity and acceleration when it passes through the lowest point. So we have to find at the lowest point. At the lowest point. Now this is for pendulum. So in other words, at the bottom, let me go back to the sketching of pendulum. So we have, this is at the amplitude. This is where your V equals to 0 meter per second, because when we swing the object and then it will stop momentarily at the amplitude before it starts to move down. So if the velocity at here is equal to 0, in other words, at the equilibrium, which is at the bottom, here is where the V is maximum, like that. So we have to put this statement where at the lowest point, velocity equals to maximum. And for that, bila kita buat macam ni, we can always get K1. Okay, it is a hidden information that we should know lah. So for that, we get the Vmax. Do you still remember what's the equation for the Vmax? So Vmax equals to plus minus E omega for that. Okay, so now that we have period, we can get the omega lah. The amplitude, we don't have the amplitude. But what we do know here is the angle. We have the angle, which is 8 degrees. So if we have the length, that would be 0.75 meters. Yes, it is 75 centimeters, so I changed it to meters. We can get this part. So this is our maximum displacement. So we can get the A. Okay, so the A is here. We can get that. We're going to use okay, we're going to use sine. So sine 8 degrees equals to the amplitude over the length, which is 0.75 meters. So your amplitude should be, let me calculate, 0.75 sine 8 degrees, it is 0.104 meters. Okay, let's put it back into the equation. Plus minus 0.104. Omega equals to 2 pi over T. The T is 1.74. And then by right, you should get the answer as suggested. Okay? And the last question, dia kata, dia suruh kita cari acceleration. And this is also another hidden information. We can see that at the lowest point, acceleration equals to 0 meter per second because it always based on the restoring force. Restoring force is always 0 at equilibrium. So since restoring force equals to ME, if the restoring force equals to 0, hence the A is also equals to 0. Next, I want to discuss this question number 15. When a 9 kilogram baby is placed in the bouncer, as shown in figure 7.5, the spring extends by 0.3 meters. And then when the bouncer is pulled down another 0.2 meters and released, the bouncer moves in a simple harmonic motion. So the next question is, we have to calculate the spring constant. So that's quite easy. We see that the baby has its own mass, and that would be 9 kilograms, and the expansion is 0.3, so that we can get the spring constant by using F equals to Kx. Okay, so F equals to, the force is the baby's weight, so 9 times 9.81, the K is the spring constant, and the extension is 0.3 meters. Sebab bila baby tu naik and then dia melendut sebanyak 0.3 meter, so itu memberi kita maklumat untuk kita punya K lah, which is spring constant. So 9 times 9.81 divided by 0.3, that would be 294.3 Newton per meter. Jangan lupa unit. Okay, that one question A. Let's find question B. Dia suruh kita calculate the frequency of the motion. So ini ialah spring, dan kalau kita tengok baik semula dekat dalam nota kita, so untuk spring ialah T equals to 2 pi set M over K. So we're going to put this one, T equals to 2 pi set mass over spring constant. Add in all the values. You do the substitution yourself, yes? And then you should get the answer as suggested. That would be, we are trying to look for the period, for the frequency. So we have to find this. Let me try. 2 times pi, and then times mass is 9 kg divided by K is 294.3. That would be 1.09899 second. So the frequency F equals to 1 over 1.099. Okay, so 1 over answer. We got 0.91 hertz. Is it the same? Yes, we got it. Okay, so that's that. Question C. Calculate the maximum acceleration of the motion. Okay, jom kita cari. So the A max. Okay, so if you cannot remember what's the equation for the A max, let's go. We have the list of equation, but we don't have to do that. We can get over here. There you go. We have A max equals to A omega squared. Okay, A omega squared. A omega squared. The amplitude is when we pull it. We pull it down, and this is our amplitude, 0.2. 0.2. Oh, we have to find our omega. So our omega ialah 2 pi over T or 2 pi F. It's up to you. Don't forget to square. So our T is 1.099. So 2 pi divided by 1.099, and then squared, and then times 0.2. So it is 6.54 meter per second. And the last one is sketch the label displacement time graph indicating amplitude and the period of the motion. And for that, kita buat dulu kita punya sketching. So, Okay, so our y-axis is our displacement. This one is in meters. Okay, the example given to us is in meters, and for the x-axis is the period for that. And then we are going to do 2 cycles. We're going to do 2 cycles, okay? But here, at this part, we have to give the value of the period. And for that, kita kena tengok dekat sebelah atas ni. Kita dah dapat 1.099. So, I put here 1.099. And then, kita buat, sebab kita nak buat 2 cycles, so this value also has to be given. And that would be 2.198. Okay, for the amplitude kita dah dapat tadi dekat sebelah atas ni. For this one 0.2, I'm gonna put in 0.2, and at the bottom over here is negative 0.2. Okay, so now let's do our graph. It's a sinusoidal graph. So it should be like that, one complete cycle and then the next complete cycle. That's it. So that's how you answer this kind of question. So I hope there are a few more questions for 7.3 and below, which means 7.1 up to 7.3. I hope you can give it a try yourself, and good luck.